Hello everyone, this is Steve. Thanks for joining me. In this video, we're going to find where the parabola generated by this quadratic intersects the line created by this linear equation right here. So let's get started. You will notice that the first equation is already solved for y. We already know that y is equal to x squared plus 7x. And the second equation says that 3x minus y equals negative 21. So what we can do is we can say that this y is the same as this y, and we can replace this y with this right here, x squared plus 7x. So we can say 3x minus x squared plus 7x is equal to negative 21 by replacing this y right here with x squared plus 7x. Distribute the minus sign gives us 3x minus x squared minus 7x equals negative 21. And I get a quadratic that I want to factor. But I can't factor it unless everything's on one side, or it wouldn't do any good to factor unless everything's on one side. So since I don't like the negative x squared, I'm going to move everything over to the right-hand side. So I'm going to subtract the 3x, add the 7x, and add the x squared to the other side of the equation, which is going to give me x squared minus 3x plus 7x minus 21. Combine those like terms. You could have done this before you moved them over to the other side also. Plus 4x minus 21 equals 0. We factor that. That's going to factor as x plus 7, x minus 3. So we get two answers, x equals negative 7 and x equals 3. But what we're looking for in this problem is ordered pairs, where these two functions intersect. So where are those ordered pairs? Well, we know that one of them starts with negative 7 and one of them starts with 3. So what we do is we find the y values that go in there with one equation, and then we check them in the other. So we take this second equation here, it doesn't matter which one you do, I'll take this second equation, and I'll plug in those x values and see what y has to be. So, or we could use the first equation. Yeah, let's use the first one because it's already solved for y. So y equals negative 7 squared plus 7 times negative 7. Which is actually just going to be 49 minus 49 equals 0. So I think that's going to be a 0. And then I plug a 3 in there. Y equals 3 squared plus 7 times 3, which is going to be 9 plus 21 equals 30. So I think this will be a 30 right here. Then what you should do is you should check those numbers in the second equation. Since we generated them with the first one, we check them in the second. So we'll do a little check up here. So I check negative 7 and 0 in the second equation. That's going to be 3 times negative 7 minus 0 equals negative 21. Negative 21 equals negative 21. Good. And then 3 minus 30 equals negative 21. Well, 9 minus 30 is negative 21. So we have two answers to this problem, here and here. What does that look like? Well, check this out. I made a graph using Desmos, and I graphed the parabola and the line, and you can see that they do intersect twice. This ordered pair right up here is the ordered pair at 330. That's one intersection. And this one right here on the x-axis itself is negative 7, 0. So when you're dealing with a system of nonlinear equations, you might have more than one intersection point. All right, I hope that helped. Thanks for watching.